just asking where did we get the value of tau from. We were given that the frequency is of this moving puck is 10 hertz, and tau actually is the period that you are acquainted with, يعني accustomed to. So the period يعني اللي هي time needed for a motion to repeat itself, and we've been recording the position of the moving puck every time equal tau. So this is being repeated, and the relation between the frequency and the period, or the tau, is that tau is the inverse of f. Having f in the SI unit, which is hertz, we can divide 1 by 10. So tau is equal to 0.1 second, and now we can use it here by substituting it. Calculate the instantaneous speed at T1, T3, and T5. V1 is equal to P0, P2 over 2 tau. P0, P2 is equal to minus 1.6 times يعني P0, P2. Actually, I can say it is x2 minus x0. Here there's something wrong here. The negative sign is not correct, so we cannot say that the speed is negative. The speed is not negative. The velocity could be negative. Yani when I find the magnitude of the speed, or the magnitude of the velocity, which is the speed, it should always be positive. Then when I express it, if it was moving, if the object was moving at this instant in a direction opposite to the direction of the positive direction of the x-axis or the frame, then I can say it is minus like 0.08 I vector, but this is not the case. The puck is moving from P0, P7, and from left to right in the positive direction of the x-axis. So even the velocity is not going to be negative at all, it is going to be positive. So V1 to be calculated, it is P0, P2, يعني as I said, it is minus 0, it's x2 minus x0, يعني minus 0.8 minus 2.4, just as we did in the previous part. It's going to be 0.8 plus 2.4, so we obtain a positive value equal 1.6 centimeter, then convert it to meter by multiplying by 10 power minus 2 over 2 tau. Also, it is converted into the SI unit. Similarly, for V3, P2, P4, يعني it is x4 minus x2. x4 is 0.8 minus x2, يعني minus 0.8, so as if it is 0.8 plus 0.8, 1.6 centimeters. And similarly for V5, P4, P6, it is x6 minus x4, which is 2.4 minus 0.8 on, so we get 1.6 centimeter, and convert all the values into the SI unit. We notice here that the instantaneous speeds are all equal, and this is expected because, as you can see, the distance covered within the same interval of time are equal. See, the distance is not increasing, so the distance being constant, being covered, is equal to the other one within the same interval of time. This means that the motion is not UARM, it is URM. So the second question is, give the characteristics of the velocity at T3 and draw it to a suitable scale. So when we talk about velocity, this means that we have to talk about a vector. We have to take direction into consideration. Give the characteristics of the velocity at T3 and draw it to a suitable scale. So the characteristics: point of application, line of action, direction, and magnitude. And a vector have these 4 characteristics, just like the force vectors that you used to deal with in grade 9. So the point of application, as long as we're saying at T3, then this means that it is going to be at point P3. The direction is, or the line of action is, horizontal line tangent to the trajectory, because the object is moving along this line. It's always the velocity vector must always be tangential to the line. هون it's since the trajectory is a straight line, so it is along it. Direction along P3, P7, as you can see, we wrote a vector here showing the direction and going from P3 to P7 to the right, يعني not to the left. And the magnitude V3 equals 0.08 meter per second is calculated in the previous part.